So for lab 3, this is the first lab where you're really given like a big pile of code and you have to edit it, add things to it. We call this file right here that you're given a sort of a skeleton code. By that I mean it's got the basic structure in place, but you're going to have to put your code in different spots. Anywhere where you see I've made little notes and little comments that say your code here, that's where you're going to have to put some code in. You're writing in this exercise, in this lab, mostly functions that support the main loop. And support is a weird word here because they really are the ones that do all the work in this lab. I just have provided for you some basic infrastructure in which you can deploy them so you're not wasting your time figuring out a fun way to use these things. The basic loop, before we go into each of the functions, the basic loop is down here, okay? And the basic setup of all the stuff is up here. We import some things right here. These are just libraries we're going to use. We set up the pins so we can use them for the switches. I come up with a list which you should remember to use later on when you're writing functions of 23, 24, 25, and 12, which is the pin numbers we're using. I set up all of the pins right here. Then I have a list of songs we can play. It's 1, 2, 3, 4, 5 long, so that's good to know. Song location, this is just where in the file structure the song is at. And then I just initialize the mixer, which is what we use to play the music. There's a variable called current song. This is an iterator you should be using, and by that I mean you'll do songs of current song to get these different like song names. Play pause state, that's a boolean, that's going to be false when the system is actively not playing, and false whenever the system is paused. There is also a variable called old switch states, and this is kind of something we got to think about for a minute. So old switch states is going to be a 4-long list, and it's 4 long because there's 4 switches, and what its job is going to be to do is to remember what the switch values were the last time through the loop. Alright, and we'll go back to this in a minute. After this we load an initial song, and we're going to load songs loc plus songs of current song plus .mp3. These are all strings. Song loc is this up here. Songs of current song, that is this list, and then current song is this. So what we're saying is we're actually starting off with the 0th song. So we're saying Genghis Khan.mp3. We then play it, and then we immediately pause it. So what's going to happen is whenever you need to start playing the music, you're going to have to look this up in Pygame, but you don't play generally starts a song over from the beginning, pause, picks it up from where it left off, unpause. Pause pauses the song, unpause picks it up from where it left off. Anyway, so if we go down, so these functions are then defined, and this is kind of like setting up modules, which you'll use, and then we have our main code loop down here. Now, how does this work? So it's a try and an except. So it's going to run this code until we have a Control-C keyboard interrupt, at which point it'll stop the music and clean up the GPIOs, the pins. What does it do in this while true loop? Well, it's going to run this forever. Our system is basically a giant loop, and it runs and it runs and it runs. And it's going to be listening constantly for switch inputs from you. And so every time through the loop, what does it do? First thing is it sets up a new list called new switch states. And then for each of the input values, for x and inputs, we say new switch states.append GPIO of input of x. So what this is saying is it's basically building up a list of 4 new switch readings in the order that they exist. So I think it's like 23, 24, 25, and 12. Then what we do, and this is the first thing you're going to have to write, is we put that new set of readings into the read inputs function right here, which you'll define up here. And this thing takes in the new switch states and the old switch states. And then ideally what would happen is it would spit an output back, and that output is then going to be it's going to be a string, and it's like depending on what it is, and that's your job to come up with how to generate that output, but depending on what it is, you're going to run different functions like the unpause or the pause or the next song or the volume up or down functions, okay? And then right after we do that, this line is important, we say old switch states equals new switch states, which that seems really weird to do, but if you think forward a minute, this is a loop. So the next time we're going to, go through this loop, the next time through, we want to know what those, like the then current new switch states are actually going to be the now old switch states. So we have to basically pass forward what we just read so that we can remember them next time through. So that's what's going on here. Each of your functions So these four functions right here, unpause, pause, next song, and volume, those are going to return nothing, the idea is, and then all they're going to do is they're going to have to like call certain Pygame functions, okay? So for example, unpause may just be a very simple one-liner in addition to maybe changing some, this Boolean right here. You're going to have to do something sort of complementary for the pause function. Next song, you're going to have to do some nice stuff there, and mostly just iterating through a list. And then volume is the only one of these four right here that actually takes an input, and this input is IncDec, and IncDec is when it's true, you're going to increase the volume by 10% of the maximum, and when it's false, you're going to decrease the volume by 10% of the maximum. And I want you to go and look at the Pygame documentation to see how to do that. Finally, read inputs. Its job, this is the big one. This is actually supposed to return something. All right, it's supposed to take in. So it's going to take in two lists. All right, new readings. Let's call it just n. And that's going to have four values in it. Let's say, I don't know, they're representing the new switch readings. And remember, the switches can either be trues or falses. So let's say the switches are all, I don't know, maybe there's two trues, a false, and then a true. Okay, and then there's old readings, which I'll just say is O. And that's going to be another list. Okay, and that's going to be what the switches used to be the last time through the loop. All right, and maybe it's all trues. Now remember, in our circuit right here, if we have our Raspberry Pi, so our Pi, the way our switches are set up, they're pull-up switches. So when they're not pushed, they actually are true. They're a high switch. So not pushed is true. When you push them, they go low, okay? They go to false, or a 0 volt, okay? So when this closes, you have 0 volts. When it's open, you have 3.3 volts, or a binary true. So what's happening is, so we want to go through, we're going to be given a list of new switch readings and old switch readings, and we want to compare them and figure out which switches, if any, have just been pushed, okay? And if switches have just been pushed, we want to, do something based off of that, okay? And we're doing this because we don't want to just see, oh, if a switch reading is false, do something, because I mean, that would say the switch is being pushed down, but the next time through the loop, if it's still pushed down, you're going to do the same event again. And what will happen is you'll end up having this weird thing where you pause, unpause, pause, unpause really, really quickly. Or you try to change one song and you change the song 45 times or something. Because you have to remember, this while true loop over here, this is not running. I mean, even though I have a 0.1, I've actually added a 0.1 second pause here to kind of put it a little bit more at a realistic time for us. But even then, that's saying this is running 10 times a second. And the average human push, if you have your little switch right here with the little thing on it, and the finger comes down, right, here's the finger now, whatever. But if this goes and pushes, this takes on the order of maybe, 0.3, 0.4, and if you're really slow, like, 1 second, right? So in the event of actual pushing, that could be 10 times through the loop, and then we don't want to call the next song function 10 times. So in a sense, what we're doing here is actually something known as debouncing. But anyways, so we debounce by going and saying, okay, we have these new readings and these old readings right here. And what you need to do inside of read inputs, its job is to go through each of these and say, okay, is there a change in a certain way? So if the new reading is true and the old reading is true, there's no change. So we could probably say maybe change, maybe there's a new list called change. That's false. Then we go to look at this first. So this is the 0th, this is the first, this is the second, this is the third. Look at the first one, right? There's no change. Then we look at this one, and then it's going, it was true, and then now it's false. This is actually a switch being pushed, right? Because switches are inactive high, active low. So this would probably be a true, a good change. And then right here again, another false. Now, important thing to keep in mind is, whoops, what did I just do? An important thing to keep in mind here is, like, let's say you had another situation where maybe new is true, true, false, true, and the old reading is true, false, true, true, okay? So again, we'd go through this and come up with our list, and we'd say, oh, no change because of this. Then we have to be careful. This one right here is a good change. We're going from an unpushed to a pushed state, while here, red is bad, we're going from a pushed to an unpushed state, okay? Because we're going from old to new readings. So we have to, your code has to basically say this is not a change and this is a change. All right. And so then what you're going to do then off of this change is go through the change and say, okay, if the change is a certain way, we have to return pause, unpause. Or if the change is the next song, like a certain way, we have to return next song. And there's an order in the lab which you have to follow, like an order of precedence. And the idea is if you're to go in and just, wipe your finger across all the switches, I want a non-ambiguous response for the system. It has to have a preference. Okay, so give this a try. Post questions on the forum if you have any problems you run into.